On the Pi, the member functions implement reasoner operations and inference operations. So it's a higher level kind of logic programming thing. And it's important for me to say at this point that although the member functions, or methods sometimes as they're called, are C++, the implementations of those member functions call Prolog in a lot of instances. And so, for instance, in our Raspberry Pi environment, using switch Prolog, you would call from inside of your C++ member function, you would actually call Prolog, the Prolog C interface, right? And so the knowledge base is implemented in Prolog, running on the Raspberry Pi. From C++, you would gain access to that Prolog knowledge base through the Prolog C interface. And then for communication, the interagent communication, that is when the Arduino sensor agent needs to talk to the Raspberry Pi sensor agent, it's doing that through what we call descriptive logics, right? And we're going to leave a reference for that too. But those are just very simple, instead of just sending ASCII formatted text or comma separated, CSV separated values between the Arduino and the Raspberry Pi. Instead of just sending that kind of format, we're sending text, but that text has a little bit more formatting to it, and it's formatted as something what's called a horn clause, and that gives you a little more knowledge behind what's going on. It's a self-describing format in a way, not as self-describing as XML. But for those that know what common logic is, it's a self-describing kind of thing. Again, we're going to have references for some of this at the end of this talk here. And here's the communication between the Arduino and the Raspberry Pi. Just showing you how some of these parts work. We primarily use serial port communications and Bluetooth when we're connecting the Pi to the Arduino, right? And the Arduino in that case would have some kind of Bluetooth shield. That's what we use to get the Bluetooth, and the Raspberry Pi already has that built in. You actually typically need something extra on the Arduino to accomplish Bluetooth, but you don't need anything extra to do serial port communication. So probably 90% of what we do is just connecting the GPIO pin serial, the RX and the TX pin and the ground, to the Arduino RX, TX, and ground, and we send serial connections and information from the Raspberry Pi to the Arduino. And what we're sending is what we call descriptive logics. And it's a form of communication that allows a great deal of transparency for those that want to know, what kind of thinking is going on inside of the Arduino and the Raspberry Pi. The fact that we're using logic knowledge bases and descriptive logics, it allows our thinking processes to be transparent to humans and understandable, and process, and you can process it by third-party software as well. So that's an important thing. Also, I want to point out here that the Arduino, the setup function and that loop function for Arduino, all it does is act as an agent request broker. It does not execute any of the agent sensor. All it does is instantiate the proper agent, and then it figures out what member functions to send messages to. That's all it does. And so you write this agent request broker only one time. Okay? You write that one time, and it can work with all of the different kind of sensor agents that you might have associated with your Arduino. And so a lot of times the code for Arduino is either is divided between the setup function and the loop function. To develop this old architecture that we're talking about, we pull all of the meaningful code out of that loop and setup, and that's stored in individual class definitions and declarations. Okay, so we just call the loop and the setup function on the Arduino, we call that an agent request broker, similar to object request broker. For those of you that from way back in the Corby days, if you knew what was going on, this is like an embedded version of that. And on the Pi thing, Keep in we show here that it's scheduled with a cron tab or system D timer, and so that agent runs the minute you turn the minute that Arduino or Pi gets power. It runs, and in our case, we have member functions that respond to SSH and that kind of stuff. And so if we need to get to the device from our intranet, and we do not try to access it from the internet, we aren't trying to deal with all of the security issues there. These devices run on our personal networks, our home networks, our personal private networks. These are not the devices as we've designed them. They're not developed to just run out there in the wild with the internet and all of the fun things that you get yourself into when we're doing internet web programming, right? So that's a general picture of the communication that's kind of going on there. And I want to point out here that between the Raspberry Pi and the Arduino, we only send back and forth something called horn clauses, right? You can look those things up. It's a form of descriptive logic. Again, we're going to give you a reference for that because we can't go into all of this. I'm out of time already almost here. We can't give you a detail on all of this, but we can say, hey, this is how we communicate between the Arduino and the Raspberry Pi. And we do this over primarily a serial port, Bluetooth, and on occasion I2C. If there's some kind of special thing that we need to do there. Okay, and so here's an example of that loop function, right? Here's the request broker, and you notice here in the loop, we're not doing anything outside of we're reading what's coming over the serial port or the Bluetooth port in this case, and then we're sending that request to the agent. In this, if you see where it says process request, we're sending that request. The agent processes it and sends back the response in this variable named agent response, and then we transmit that agent response back to the Raspberry Pi. That's all that's going on here. And so we have a serial port version of this and a Bluetooth port version of this. And it's just we include this code here so you can just see that we are not trying to do any of the sensor agent processing inside of that loop. That loop just calls the sensor agent that has already been declared, right? And so here are the wires for GPIO programming between the Raspberry Pi and the Arduino, thanks to Oscar Leon here. There's a nice diagram that just simplifies. You got the receive pin and the transmit pin. We got voltage connection, and we have a logic converter there because the Pi has a 3.3 volt thing going on, and a Arduino has a 5 volt thing going on. So we have a logic level, a LL converter there. This talk, there is a sufficient amount of programming going on here, and there's some wiring going on. And so, this is for folks that are passionate about this kind of thing. This is not, if you're not the kind of person where you're interested in the wiring or you're interested in low-level programming, then you're going to not find this attractive at all. On the other hand, if you are the kind of person that want complete control of the software and the hardware, then you're going to like this because this is a very low-level approach to getting it done. You have a whole bunch of control over everything, and you can decide, how and what your communication is going to be and how your device is going to communicate and what protocols you're going to implement. Here's a simple example of the Raspberry Pi code that actually calls the Arduino code here. So notice that this is we're using a connectivity sensor on the Raspberry Pi, and it's talking to the veneer sensor, which is a lower level method. So these are two methods right here. One method has been implemented on the Raspberry Pi. The other method has been implemented on the Arduino. And this is just the Raspberry Pi sending a request to Arduino to measure, to do a connectivity measurement, right? So you can take a look at that code. Clearly, this is the kind of thing you might have to go back to and look at and stare at it a couple of times. And we left there's some URLs that at the beginning of this talk that we provide that gives you many more examples of this, and where you can drill down. In some cases, you get all of the code for some of the projects. And so, we have a lot of presentations that go into various levels of details about this kind of old programming techniques using the Arduino and the Raspberry Pi. And so if you're interested in this kind of thing, just go to those links that we gave at the beginning of the talk, and you'll find a lot more code and a lot more talks, a lot more discussion, and you'll be able to engage the rest of the community that's doing this kind of thing. Okay, and so we just kind of gave you an overview of the architecture and how we're approaching this concept of a knowledge-based embedded system. And one of the things that we wanted to measure with a system that we recently built was the salinization. How saline, how much salt was in a soil that we in a couple properties, in a couple places that we are, we find ourselves at. And one of the problems, or some of the problems that are caused by salinization, plant dehydration, it can choke plant reproduction, mess up your garden for some reason, and if your plants or your garden, your flowers stop growing. In some cases, it could be due to salinization, soil degradation, soil erosion. These are very big problems for soil worldwide. And so the ability to detect high levels of salinity and do something about it, that's actually an issue that people dealing with climate change, they're very much concerned about. It jacks with or messes with crop yield. It has negative effects on drinking water, and and overall it threatens our environmental resources globally. And so we just, in the citizen science community, are interested in developing our own kind of, a connectivity monitoring or checking salinity in our local resonances. And so some of the projects that we do for these embedded devices involve salinity and connectivity. And so we've implemented a few of those using the Raspberry Pi Arduino and the Raspberry iOS Trinity. Right? And just so that you get a picture of what that knowledge base looks like, right? Here is just a snippet of it. It's actually not too much bigger than this, There might be another 50, 60 lines of code, and then you would see the whole thing. This is an excerpt of the knowledge base. This is what some prologue looks like for those of you that have never seen it, or for those of you that have forgotten what it looks like. This is what some looks like, and this is giving some of the knowledge about salinity, that if it's under 500, the measurement in this case, and we're talking about the salinity that's in water, then the water is very safe to drink, right? And if it's the other way around, right, say that it's over 500, but let's say it's under, a certain level, then the water is drinkable, but, it's not as safe as the first case. And then in that last case, you can drink it, and if you need to drink it in order to survive, you're stuck somewhere, and, you can't get safe water. Just, if you have salinity between 600 and 900, it's not going to kill you. But it might cause other issues. But in either case, this is an example of salinity, a salinity knowledge base that's running on the Raspberry Pi, and this is actually executable prologue that you're looking at right here. And so again, the languages involved are C++ and Prolog for what we implement at CTEST Labs, and in any of the projects that we are doing where we are talking about embedded devices. And as an example, when we talked about knowledge base and some of those operations, the reasoner operations, on the Raspberry Pi, here are some of the kind of conclusions that the hardware can come up with, our system. it can let us know that we're talking about a high level of dehydration. And because of the kind of system that we have it connected to at CTES Labs, it's able to actually take action. Once the system comes to the conclusion that we have a high level of dehydration, there's a level 2 treatment that it actually will perform in that situation. If it after taking measurements and doing some reasoning, it comes to the conclusion that conductivity is high, and if say we're measuring in an aqueous substance, the salinity levels are unacceptable, and a certain kind of purge is necessary for the equipment that we have. And then this last example, salinity is, let's say, less than 500. We're cool and there was no action taken. But those are the kind of conclusions that the hardware, this embedded device that we're talking about, or devices, in a generic way, can come to using this O.L.D programming technique approach, right? And so, whereas you could get these kind of monitors, or at least monitors that deal with the same subject matter off of, let's say, an Amazon or somewhere, they won't be knowledge-based monitors. They'll be simpler. They're not that they're not useful. It's just these type of devices that we're building, they're more useful, and that's why we build them, and that's why we use them. Okay, and so here are some OAB resources for these O.L.D programming techniques. These are resources that we use and that we can recommend and that we trust, right? There's no fake news in these. These are written by well-respected folks in all cases, and they're well-sourced. So in this day and age of information and talks where people are coming out of who knows what kind of bag, we're giving you our resources right here. Knowledge, representation, and reasoning. Man, and it's a good read too for those of you that are interested in those kind of things. Agent technology, this is from the NASA series, very good stuff. Answer set programming. I won't say much about that outside of those of you that have the courage, and the bravery. Dig into it, and you might be surprised at what you find. And the programming machine ethics, we are very much worried about certain classes of software systems that are being deployed today in autonomous environments. And this book right here gives you a lot of programming techniques and subject matter that lets you develop knowledge-based systems and thinking machine systems with an eye towards ethics. So I cannot recommend these enough. They are legitimate, and I think good reads in their own right, and would be worth the time for any of those of you that are interested in this kind of programming and development. So these are OAB resources for O.L.D programming techniques, right? And also, we brought up the descriptive logics, and we talk about Prolog and sending descriptive logics back and forth between those two types of devices. I wanted to let you guys know there's an IEEE kind of standard called the Common Logic Standard, and there's Common Logic Interchange Format and Conceptual Graph Interchange Format. For those of you that are interested in doing that kind of programming and understanding more about what we're talking about when we talk about descriptive logics or Prolog in general, or logic programming in general, these are very good standards. It's a very good standard. I think, again, it's a good read. I use it as a reference all the time, and when we do talks about the autonomous robot programming. And that's really our main gig. A lot of these devices that we're talking about, we take those devices and we immediately attach them to autonomous robots. And so there's a big connection between the Raspberry Pi Arduino and Raspberry Pi iOS, that trinity. There's a big connection between that and programming autonomous robots. And if you're interested in doing it in a standard kind of way, the ISO 24707 standard. I think there's one, maybe 2019, 2020 also that's out. I'm not sure. But this is good enough for me. I just want to provide, we want to provide you guys references for this for future, for your future reference. And one more thing here. If you are so inclined to, you really get a charge, or you're excited about citizen science and what you can do in terms of helping with the environment issues we might have, climate change, or sustainability goals that we have, international sustainability development goals, like the UN International Sustainability Development Goals. We would want to point you at the national labs, the Department of Energy National Labs. They do a lot of good work. There's a lot of outreach programs for schools and for interns and people just graduating from college, or people just going into college. If you're interested in that kind of thing, and you get charged by the possibility of developing your own monitoring devices, or your own autonomous thinking monitoring devices, you might find these very, very good resources. And just in general, our Department of Energy, they're doing an amazing job in these 17 national labs. They're just amazing. If you get a chance to check out their YouTube channel for the Department of Energy, boy, I think you're going to be surprised at some of the stuff they've got going there. All right. It's been fun. Thank you. And now, any questions?